to be able to do anything right. Okay. First things first, we're going to do a couple definitions. So the first definition is the definition of power. It's a term I'm going to try to use more because it is a proper term, and I have a hard time of not using it sometimes. So a power is something that has an exponent. So for instance, if you had something like 3 to the power of 4, this entire thing is a power. Yes, sir.
Is this where we like adding and subtracting?
Yeah, that's what we're going to be doing. Yeah. So the whole thing is called a power. So when you hear me say, like, write it as a single power or any sort of terminology like that, that's what I'm referring to, is the entire thing. It has two different parts to it. One part is the base, and the other part is the exponent. Base is the big thing. Exponent is the little. Wonderful. That's a power. What does an exponent, because that's what we need to learn next, what does an exponent mean? So if I have 3, and we say to the power of 4, that's how I describe this power, 3 to the power of 4, what does that actually mean? What is the 4 telling us to do? Yeah, give it a shot, man. Close. Yeah, it means multiply the base by itself 4 times. That's why you're super close. So it means that whatever your base is, multiply it by itself that many times. So for instance, if we take 2 to the power of 3, what that really means is 2 times 2 times 2. So you're taking the base and multiply it by itself 3 times. Like this. 2 times 2 times 2. If you put that in your calculator, like, you could evaluate it. You could calculate it. We're not going to be doing a lot of that, but you could calculate it, and it would equal 8, right? But for the most part, we're just going to be writing things as powers and leaving them as exponents instead of calculating and evaluating. So if you look at the next one, if you ask yourself, what does this truly mean? This means take the number 2, multiply it by itself 3 times. So you have 2 times 2 times 2. Then times the number 2 4 times. So times 2 times 2 times 2 times 2. So that's 2 to the power of 3 times 2 to the power of 4. But if I wrote it all out in long form, I mean, that would be ridiculous to write like that, but you could. You can see that what you really have here is you have 3 2's multiplying times another 4 2's multiplying. We could actually just write this in much simpler terms. We could write this as 2 to the power of 7. Because realistically, that's what we have. We have 1, 2, 3, 4, 5, 6, 7. We have 7 2's. Perfect. This idea that if you have 2 powers multiplying together, you could rewrite it like this gives us an exponent law. It's the first one that you would have learned last year. I don't think you learned it in grade 8. I think just grade 9. And that law would have been, if you have two exponents, you could add them together if you're multiplying the base. Right, so if we look back at the question we just did, this is the exact same thing as doing 2 to the power of 3 plus 4. Right? 3 plus 4 is 7. So when you're multiplying bases, you add exponents. Mathematically, it gets written like this. You're multiplying bases. That means you add the exponents. That's our first exponent law. How many people actually think they remember that? A couple of you guys are like getting kind of close on it. Yeah, good. So multiplying the base, add the exponents. The way we see this, we have about 6 questions here we're going to try together. So if I look at this one, I'm multiplying the same base. That means I can add the exponents. That means this thing would turn into 2 to the power of 7. And what I've done is I've written my question as a single power. It's also called simplified. That's the term you'll usually see. It'll say simplify or simplify the following. You do not need to calculate it or evaluate it. I'm looking for you to write it as an exponent. Yeah, Kai.
What one would you prefer?
This would be the one we would prefer. And it would be called simplified form. Yeah, of course. And we will have like bigger questions, and you'll see how it looks much neater once it's written like that. If you look below, that's m to the power of 3 times m. These are the same base being multiplied together. So we combine it to become 1. And then we add the exponents. But there's no exponent there. Yeah, Deshane. Yeah. So if there's no exponent, that's an invisible 1. They don't write to the power of 1. Okay, so just so you know, if there's no exponent, it means 1. So if we have same base multiplying, we add the exponents 3 plus 1. This is now a single m to the power of 4. There's a single power, simplified form. Seems okay? Go to the right. So the first one, if I was to verbally say this, it's 3 to the power of 3 times 3 to the power of 2. Those are the same base. They're both 3. So then I can add the exponents, 3 plus 2. That is 3 to the power of 5. Cool. The fourth one is a little bit different. If you look at the fourth one, first off, there's no symbol in between. All right, so if I was to look at this fourth one, I would notice that there's nothing in between the letters. Right? This just says M, and then there's nothing there, and then N, and then there's nothing there, and then M again, and then there's nothing there. So if there's nothing in between the letters, what does that mean to do? Yeah, give me back there.
Time.
Yeah, right? It means to multiply. So when there's nothing there, it means multiply. And we can also represent multiply with little dots. That's typically how you'll see me do it. I try to avoid using X's for multiply because then it looks like the letter X. And sometimes we use the letter X in math. So instead, I'll do multiplication symbols with dots. Or I just won't even put it. If there's nothing there, it means multiply. Cool. We're going to try to simplify this. To simplify this means to write things as single powers if you can. The trick is that you have to have the same bases together, right? So when I'm multiplying these together, the m's can only add with the other m's. So this is m to the power of 3, m to the power of 4 will become m to the power of 3 plus 4. The n's will do their own thing. So this is n to the power of 2, n to the power of 5. So n to the power of 2 plus 5. If I was to finish this off, that means my m would be to the power of 7. 3 plus 4 is 7. And n would be to the power of also 7, because 2 plus 5 is 7. Same letters can go together. If they are different letters, they cannot combine. You just leave them the way they are. That thing is called simplified form. Cool. That's what we see the most of. So like from this moment all the way up until Math 30-1, if you go that route, that is what we see the most of, is letters kind of written together like that, and you just have to understand which ones can go together and which ones can't. Same letters go together, different letters don't go together. We got 2 more here. The first one, that's just a good reminder that we have same base. They're both 8. This would be 3 plus, that's an invisible 1, to give me an answer of 8 to the power of 4. And the last one. The last one gives us another problem that we haven't seen before. It's giving us brackets. So when you have brackets against brackets, in fact, if you have just anything against brackets, what does it mean? Give a shot. Yeah, it means multiply. Pretty much if you don't know what something's going to be in math, it's probably going to be multiply. I'm not sure why that is. It's just like mathematicians got lazy over time. But if there is nothing in between brackets, it means multiply. So this is the same thing as saying x times y squared times y cubed times y to the 4. Those mean the same thing, right? One of them I've rewritten with multiplication symbols. The other one, they've just gotten lazy and not putting the multiplication symbols. It means the same thing. Again, same letters can go together. Different letters can't. So when I look at this question, I have x, and there's no other x's in this question. That means it can't combine with anything, but it'll still be there. This will be x to the power 1. It'll just be sitting there. The y's, I have y to the 2, y to the 3, y to the 4, will become y to the 2 plus 3 plus 4. That means this simplifies to be x, y to the 9. The other order you could write it in, good question. You could write it like this, technically. Oh, you had? So you could technically write the y's first. The way we prefer it would be like this. Typically, we go alphabetical order. But that isn't like a have to follow rule. It's just something we do. So it kind of looks the same. Yeah, but do you have a question? No? Had one. Went away. Okay. Good chat. All right. If we looked at that thing right now, that answer I've got, this one in the red box. What's the exponent on the x? Jake, give it a shot.
Exponent 1.
It is, right? So this, there's an invisible 1 right there, right? So just because I didn't write something doesn't mean it's not there. And you will get questions from time to time where it'll be like, what's that exponent? Right? That's x to the power of 1 times y to the power of 9. That's what that means. Yes, sir.
Can you write it in the 1 and it still be correct?
Yeah, like if you put the 1 there, I would never dock you marks for that. And you'll see people like all the way in grade 12, they'll still write that 1 there because it just helps them visualize it. And I'm 100% cool with that. The typical way to write it would not be to have the 1. It just look like that. So on a multiple choice test, like this would be the answer that would show up on the test. If you want to write a 1 in there, yep, that's cool. Awesome. Before we move on to practicing some questions, I want to give you an example, an extra example. We'll put it up here in this little corner. This extra example is a good example of what not to do. So let's pretend we have m to the power of 2 plus m to the power of 3. Okay. Give it a shot, yeah. Yeah, so like people look at that thing and we get so in the habit of adding our exponents, right? Because that's what we do. Is that we forget that the only way you can add your exponents is if you're multiplying your bases. That is adding your bases. If you're adding your bases, you can't combine those things. There's no like way to write that as a singular power. Right? It has to be multiply. If it's not multiply, then we can't do anything with it. Now we'll learn some more. Right? Today all we learn is multiply. We'll learn divide in like 20 minutes. And then tomorrow and next week, and when we come back, we're going to learn some other things. So we'll learn like exponents with more exponents. We'll learn negative exponents. We'll learn fractions. We'll learn all kinds of stuff. But if you don't know a rule, then you can't do anything with it. All right? So that's key. This is addition, not multiplication. So that means we cannot combine these together. That has to be a multiply sign. Cool. All right. We got a bunch of practice questions right here. Mine looks a little different than yours. I think yours is a little more organized than that, isn't it? Mine looks like mine edited a little crappy. But it's the same practice questions. So if you want to go ahead and try to write all of those in simplest form. So go ahead and try to like combine those things. I'll give you lots of time, work independently, and then I will go through them and write my answers on the board so you can see if you got it right or wrong. The first one's pretty straight up, right? That's 6 to the power of 3. That's how we describe it. Times 6 to the power of 5. I want to add my exponents. So 3 plus 5 would be 6 to the power of 8. That's one of those ones that's like pretty straight up. Yes, sir.
I was going to say it wasn't math, but put 3 plus 5.
No, like if you're just going right to the answer, that's fine. Yeah. I usually just show it the first few times so people see where I'm getting numbers from. And then hopefully we kind of get on that trend and we're good. The next one, B, is one that people do right but get wrong. Okay, so if we're looking at this, it's negative 2 to the power of 3 times negative 2 to the power of 5. We're going to add those exponents to become 8. And I think if I looked at a lot of sheets, we would get negative 2 to the power of 8, like that. Now, we got a few issues here. First issue is what you just described, is a lot of people would have said negative times a negative is a positive, and they would have wiped out the negative exponent, the negative altogether. That's one problem. Technically, you're right. But if you had something like this, negative 2 to the power of 6, those negatives wouldn't cancel out. Which is why I'm like, technically you're right. That's the first problem. The second problem is that that's actually just not correct the way I have it written. The reason it's not correct is because a negative is like its own thing. So right now, this represents a negative, and then 2 times 2 times 2, 8 times. That's what that's technically saying. So 1, 2, 3, 4, 5, 6, 7, 8. But that's not what we had. What we had in the question was we had negative 2 times negative 2 times negative 2, 8 times. And there is a difference, right? If I told you had negative 2 something or 2 of something, that's very different. Is that 8 times? 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. That's very different. So when you write your answer, you have to put brackets around your base. By putting brackets around your base, you're saying that that negative is what you want to be multiplying over and over and over again, not just the 2. If you don't have brackets, you're telling me that there's 8 2's and then a negative symbol, which is wrong. You want brackets around it so you have 8 negative 2's, like my green one. Yes?
So the top thing would still be bracket negative 2. It would still be in brackets negative for the top one.
Like the example, the new one I did?
Yeah.
This one would still be bracket negative 2 to the power of 9.
Yeah. Okay.
Yeah. But you have to have those brackets.
Yeah. Okay.
Okay. And now to this whole like 2 negatives make a positive thing. Because that's a good, I know, but you were not the only one. I think you said it. But I heard a lot of people doing it. I saw a lot of people doing it. 2 negatives become a positive is correct. In fact, an even number of negatives become positive, right? So if I had negative 2 and I had 4 of them, that would become positive. But if you have an odd number, it actually stays negative. So for instance, like negative 2, negative 2, negative 2, that's an odd number of them, would stay negative. Because every time you multiplied by another negative, it changes the symbol. So it would be like negative 2 times negative 2 is now positive. Times a negative, now it's negative. Times a positive, now it's positive. Times a negative, now it's negative. And it's going to keep switching the symbol back and forth. So the idea that 2 negatives will cancel out only works if you have an even exponent. If you have an odd exponent, that trick won't work. All right, so just like forewarning those people who maybe got rid of their negative sign. Cool. I apologize for the fuzziness that is going to be coming up on our TV. Hopefully it fixes itself. This is the worst room in the school for internet. So the internet will just kind of lag out a little bit and it'll go fuzzy, but it usually comes back. Okay, so your proper answer for that one would be bracket negative 2 bracket to the power of 8. You have to have brackets around that negative. For C, that's a pretty straightforward one. So that would be 9 to the power of 7. 4 plus 3, 7. The next one, a to the power of 4 times a to the power of 2. 4 plus 2 is 6. A to the power of 6. Next one, that is b to the power of 7 times b to the power of 1. So it'd be 7 plus 1 is b to the power of 8. Wonderful. F, which I think is actually on the top of the next column for you. If I'm matching those up properly, the m's go together. So m to the power of 1, m to the power of 4 becomes m to the power of 5. I have n to the power of 2, n to the power of 6 becomes n to the power of 8. I'm not sure why my files kind of changed the way it looks when I open it up, but it did. So you have m to the 5, n to the 8. Cool. Up here, they get a little bit more complex. You just got to remember that the same letters go together, right? So A's are only going to go with A's. So a to the power of 3, a to the power of 1 becomes a to the power of 4. B to the power of 7, b to the power of 2 becomes b to the power of 9. C to the power of 1, there's an invisible 1 there. C to the power of 5 becomes c to the power of 6. We cannot combine those because they're not the same letter. All right, don't overdo it. Sometimes people start adding 4s and 9s and 6s. All right, don't overdo it. Different letters can't combine. This one, just a little bit bigger now. So when I'm looking at my letter X, I have x to the power of 2, x to the power of 4, x to the power of 1. It become x to the power of 7. So that'd be 2 plus 4 plus 1. Yes, sir.
I just wonder, would we ever use this in like our daily life?
Probably not. And you'll probably never use any of this stuff I show you in your daily life. Who does?
I think a lot of stuff.
Sometimes. I guess exponents sometimes pop up. Pretty rare, though. Pretty rare people do math in their daily life. They do.
You're a math teacher, then it's
Yeah, I do math pretty much every day. But other people who live on the world, the only math you usually do is maybe some measuring, maybe some counting, money math, basic math. It's pretty rare you're doing exponents on things.
I think biochemists, engineers do.
Yeah, anything with sciencey, like engineers would do their math for sure. Right? Anyone in that science world would have to do math. If we look at our y's, we have y to the power of 3, y to the power of 1, another y to the power of 3. That's y to the power of 7. And our last one, we have z to the power of 5, z to the power of 1, z to the power of 4. It would be z to the power of 10. Cool. That was a little more complex because there was 3 letters each that you had to be looking at. The last 2, we had lots of people getting stuck on because it just looks different, right? It looks unique, and we're not sure how to handle it. The base is just becoming a fraction. So that means my base needs to be a fraction. And I put it in brackets like that for now. The exponents, you still add together. So 5 and 4 would add to be 9. Again, you have to have brackets. If you don't have brackets, then you're saying that 9 only goes with the 3. By having brackets, you're saying that the 9 goes to the entire fraction. This is 3 divided by 7, 9 times. No bracket says I have 9 3s and 1 7. Those are 2 different statements, right? So you have to have brackets around your base. The last one, we're going to follow that same rule. So x divided by y is my base. 2 plus 8 is 10. Wonderful. It's your multiplying rule. Hopefully pretty simple. Once you get rolling with it, it's kind of I'm just adding. It's really easy. And once you get a hang of it, you probably rip through it, right? The second rule, which has a few more common errors where we mess things up, is going to be our division rule. We'll start by just looking at one of the division questions. So what does 10 to the power of 5 divided by 10 to the power of 2 mean? So 10 to the power of 5 means you have 10 or 5 tens being multiplied together. 1, 2, 3, 4, 5. Then you have your fraction, so divided by. 10 to the power of 2 means that you have 2 tens being multiplied together. That's what that actually means. It means you have 5 tens divided by 2 tens. Wonderful. Now, to simplify these things. To simplify these things, what you need to understand is that when you have a 10 and you divide by another 10, they are going to, what you've probably heard is, cancel out. Right? Something divided by itself equals 1. So we say they cancel out. So essentially, this 10 will cancel out with this 10. And this 10 will cancel out with this 10. And all I would have left is 3 10s on the top. 10 times 10 times 10. Which we wouldn't write that way. We would write it as 10 to the power of 3. Yeah. Perfect. And that's exactly what the rule is. So if you understand like what's happening, it'll lead you to our next rule. And our next rule is that when you're dividing, you get to subtract the exponents. So that's called our division rule. That's what I refer to it as. It's actually called, I think, the quotient law for exponents. Same with like our multiplication one is actually called a product law for exponents. But I don't like using the word product and quotient. I use multiply and divide. So our division law is that you get to subtract the exponents when you're dividing. If you look down here, I've written this out in 2 different ways. So this means dividing. This means dividing. Means the same thing. When you're dividing, you subtract exponents. Honestly, I don't use it a lot, this rule. More often, I like to picture what it actually means and that they're canceling out. And then I figure out how many are left over. But if you want to do the subtraction, that's fine. Just make sure you're doing the top number minus the bottom number. That's important. All right, so notice that the order matters. It's top, subtract, bottom. And it always has to be that way. Yep. It's technically going to become negative, which creates a problem for us because we're not actually allowed to write negative exponents. So I think I have a couple examples like that coming up, and then I'll talk like how I tackle those questions. So her question was, if your top number is smaller than your bottom one, you get a negative. That's true. You would get a negative. And we're not allowed negative exponents. So then we have to deal with them in a certain way. Okay, let's do some examples together so I can show you what happens when that pops up. Let's look at these two. So the first one is 2 to the power of 6 divided by 2 to the power of 4. That would be 2 to the power of 6 minus 4. That is 2 to the power of 2. Right? Because we're dividing. So we subtract exponents. The next one is m to the power of 3 divided by m to the power of 1. Right? There's an invisible 1 there. So that would be m to the power of 3 minus 1, which is m to the power of 2. Dividing, subtract the exponents. These questions also mean divide. Right? They're just written differently. They're written as fractions. That's how we'll almost always write them. And we'll almost always write them as fractions. So we're looking at this. This is x to the power of 5 divided by x to the power of 3. That means I have x to the power of 5 minus 3, which is x to the power of 2. The one below, we've got a little bit of a problem. We've got more than one letter all of a sudden. So now I need to match up letters with each other. So these x's would go together to become x to the power of 5 minus 3. These y's would go together to become y to the power of 4 minus 2. to give me a final answer of x to the power of 2, y to the power of 2. Again, sorry for the fuzziness. All right. This one. This is an example of like what she was just asking. So what happens when you got a bigger number on the bottom? So I'm going to show you one way to do it, like the mathematical way. And then we're going to talk about the way that I picture these things actually happening, because I find that's easier. So if I'm looking at this, I have x to the power of 3, x to the power of 5. Technically speaking, this means it's x to the power of 3 minus 5. 3 minus 5 would be x to the power of negative 2. And negative exponents are not going to be allowed. So we will learn in a negative exponent rule one day on how to like deal with that. But essentially what happens is you take your entire power and you have to put it on the other side of your invisible fraction that's going on. So technically that thing is divided by 1. And you would move that power to the bottom. But in all honesty, I find that kind of confusing. And I don't like rules that don't really make sense. And that is a rule that doesn't really make sense. You're like, I don't get it. Why would you move the power to the bottom? That doesn't make sense. So instead, the way I like to do these questions is I like to think about what is happening. On the top of that fraction, how many x's are there? There's 3. 1, 2, 3. Divided by. On the bottom of that fraction, how many x's are there? 1, 2, 3, 4, 5. And what I would hopefully realize is that while these x's start canceling out, I'm going to run out of x's on the top. And I'm going to have x's left over on the bottom. So this converts to become fraction x squared. And on the top, you have nothing left. So you put the number 1 as a placeholder to show that there is a number on top of that fraction. That's how I like to do questions like that. That's much easier than negatives and then trying to deal with negatives and remembering rules about negatives, about flipping powers to other sides. To me, that's confusing, and it doesn't work out in the long run. Instead, I like to look at the original question and be like, all right, I had 3 versus 5. That means 3 and 3 will cancel out, and 2 will be left over on the bottom. That's how I do it. To make it even a little bit more like corny, and when I teach Math 10C, I'm a video game guy. I like video games, and I like, I don't know, even just simple computer games where you like go to war with things, right? So if I had like 10 guys and somebody else fought with 12 guys, if we fought, they would win because they got more people, and they would have 2 left over, right? Like my 10 would kill their 10, and their 10 would kill my 10, but they would still have 2 left over, and they'd win the war. That's how I picture fractions. So I look at this, and I'm like, all right, there's a war, there's a battle going on. There's 3 of these x's fighting 5 of these x's, right? The bottom's going to win. And they would have 2 left over from the war. So that's how I write it out. They have 2 left over. Honest, swear on my life, that is how I do fractions. And that is how I do exponents at every level of math. From math 9 to math 12. That's how I think about fractions. I don't know.
When did you
It just works. Civ or like, what's the board game? Risk. That's what I'm thinking of. Whoever got me there. Thank you. Like that's exactly how Risk works. Right? You go to war with characters, and I don't know, they cancel each other out, and whoever has more wins. Yeah, Civ's the same thing.
Just more fun.
Yeah, faster paced.
And Gotti has nuclear weapons.
Exactly. So in the future, that's how you'll see me handle things. So if I looked at a question like this, I actually don't use my subtraction law. The way I do these questions is I look at it and I say, all right, if I look at just the x's, there's 1 on the top fighting 3 on the bottom. Which side would win, and how many would they have left? The bottom would win, and they would have 2 left. So it would be x to the power 2 on the bottom. Then I'd look at the y's, and the y's would kind of go ahead and do their thing. I have 4 on the top. I have 1 on the bottom. If they went at it, the top would win because they have more. So the top would win, they have more. And they would have 3 more. So my final answer would be y to the power of 3 divided by x to the power of 2. I don't even do the subtraction law. I'm literally just thinking, how many would I have left over? Much easier than using negatives, and honestly kind of fast once you get going at it. Does that make sense? Am I crazy talking about video games? Yes, sir.
Why is the Y ball on top and not the X?
Good question. So when they're battling, you think of them as like separate things, right? So the x's can only go and cancel out other x's. So if I have 1x here and 3x here, and I pictured just them, kind of like they're going to war, right? So I have 1 on the top, 3 on the bottom. Who would win that war? The bottom, because there's more of them, right? 3 is more than 1. So that's why the bottom gets to keep their x's.
Okay.
And they get to keep 2 of them because that's how many we cancel out.
Okay.
And then I do the same process with the y's. So if I have 1 y on the bottom and it goes over 4 y's on the top would win that battle because there's more of them.
Okay.
And there'd be 3 more of them.
Makes sense.
Who would ever thought that playing video games would help you on math, maybe? Cool. The division law is harder. It is. It's more confusing because it's possibilities of negatives and stuff like that. So that's typically the one we'll mess up on more. There's a bunch of practice there. So same deal. I want you to try to write those things as singular fractions. You'll see a couple of them get a little tricky. I'll give you a few minutes again to try, work your way through them. You can ask for help if you want, and then I'll go over them all together. I think the first few actually are pretty straight up, and then the right side gets a lot harder. So this one is 7 to the power of 8 divided by 7 to the power of 3. I think most people are just recognizing that would be 7 to the power of 8 minus 3, which is 5. So that first one is 7 to the power of 5. For B, that would be 5 to the power of 5 minus 4, which is 5 to the power of 1. Remember that we don't actually write the 1, so we would just write that as 5. If you put an exponent of 1, you're not wrong. Right? Just understand that that's how it'll show up on a multiple choice test. Just 5. And that it means there's an invisible 1 there. Perfect. This one. This is a good example of those negatives and the brackets make a difference. So this is saying that the base is -4. So you need to also have brackets around that base. If you don't have brackets, you're wrong, right? By not having brackets, you're saying that 4 is to the power of something. I'm saying -4 is to the power of something. Those are two different concepts. So you have to have bracket -4 to the power of 2. Because 7 minus 5 is 2. Fractions. That's 8 to the power of 6. A fraction means divide. So that's 8 to the power of 6 divided by 8 to the power of 4. We subtract. That's 8 to the power of 2. The way I like to envision it is that I had 6 on the top. They attacked the 4 on the bottom. The top would win, so they get the number. And there would be 2 left over. Technically, on the bottom, there's still a placeholder of 1. So I am seeing people sometimes write that divide by 1. You're fine. You're not wrong. We won't write it divide by 1. We'll just put 8 to the power of 2. But if you put divide by 1, you're still right. That's okay. If you look at this one, the brackets, again, they matter. So this will be -7 in brackets to the power of 3. Again, if you wrote divide by 1, you're not wrong. Right? You're fine. You're just writing it different than I do. This one, a to the 9 divided by a to the 7. You're going to subtract your exponents. That should become a to the power of 2. Fantastic. The right side starts to get a little more complicated. So left side's a little more basic. The right side, we run into some new things. N to the power of 10, n to the power of 7. 10 minus 7 is 3. That one's still pretty straight up. It's just n to the power of 3. Oh, did I miss one?
Yeah, G.
Oh, it's way down here. Oh, and that's a good one. I needed that one too. I was looking for one. Oh, I know there's another hard one there. This one. B to the power of 8 divided by b to the power of 8. I'm going to write it as a fraction so that we see it in another way because this happens a lot too. These mean the same thing. Okay. If you're doing your subtraction rule, 8 minus 8 is 0. Perfect. B to the power of 0. And you have to put the 0 there. If you don't put a number there, what does that mean? It means 1, right? So you have to put 0. But realistically, we don't write that as our final answer either. There's a simpler way to write that. If there's 0 of something, which is what we're saying, then you shouldn't have any b's at all. And instead, you have to put a placeholder number to represent that, and that placeholder would just be 1. So that is actually what I was looking for, just the number 1. If we want to write it out to kind of see how it goes, b to the power of 8 means there's 8 b's. 1, 2, 3, 4, 5, 6, 7, 8. Divided by. On the bottom, there's another 8 b's. 1, 2, 3, 4, 5, 6, 7, and 8 b's. These would all pair up and cancel each other out. These b's would cancel these ones, these ones, these ones, these ones, these ones, these ones, these ones. So there's 0 left. And we know, because we did this with earlier questions, that if there's nothing left, the placeholder that we put is 1. So this would be a placeholder of 1 on the top divided by a placeholder of 1 on the bottom, which is just 1. Okay, so that's why this rule of if there's nothing left, you put 1. That's why. Cool. If you put b to the power of 0, I'd still mark it right, at least for now. Right? In a couple of days, not so much. But if you did today, that would have been okay. All right, up here. We start to get into these double letters. So we have a to the power of 10, b to the power of 6, divided by a to the power of 2, b to the power of 3. The a's will match up. So that 10 minus 2 will be a to the power of 8. The b's, I got 6 minus 3 as b to the power of 3. Wonderful. The next one. We start to get into our problem of there's more on the bottom than the top. So when there's more on the bottom than the top, your answer has to go on the bottom. So for instance, I look at these a's. If I have 10 a's on the top and they battle those 12 a's on the bottom wins. So the bottom would still have the letter A, and it would have 2 of them. So that's a to the power of 2. Then the b's would go. If there's 3 b's on the top and they battle 1 on the bottom, the top would win, and it would have 2 left over. So this would become b squared divided by a squared. Squared means to the power of 2. The a's went to the bottom because there was more of them. The b's went to the top because there was more of them. And that's how you decide which place things go. All right, this one. When you have more than one letter on the top, like this, and they're the same letter, I actually like to combine those first. So x to the power of 3 times x to the power of 4, I combine to become x to the power of 7. On the bottom, I still have x to the power of 12. And it hasn't changed at all. Then it's easy for me to look at those and subtract. But I combine the top first, so it's one letter on the top. Now I can look at it and say, all right, there's 7 on the top, 12 on the bottom. If they battled, the bottom would win, and there would be 5 left over. On the top, there's nothing left. I put a placeholder value of 1. So this is 1 over x to the power of 5. Perfect. Last one. I'm doing the same trick. So I have 7 to the 3 times 7 to the 6 on the top. I want to combine that to become 7 to the 9 divided by 7 to the 5. Then it's easy for me to go 9 minus 5 is 7 to the power of 4. Wonderful. Those are our most basic exponent laws. It probably went kind of smooth. You're like, oh yeah, okay, I got this. That's good. We need to be really, really good at those. Make no mistakes ever good at those. Because we're going to see them a lot for the next few years. So today I'm going to hand you a practice sheet.